And welcome to Technology Tap. I'm Professor J. Rod. In this episode, cloud concepts. Let's tap in. All right, welcome back to Technology Tap. I'm your host, Professor J. Rod, and today we begin a deep journey into one of the most transformative revolution in modern computing, cloud concepts and virtualization. This is a story not just machines, but of imagination, a story of how we learn to take one physical system and make it many. Today, the cloud is everywhere, powering your phone, your bank, your classroom, your hospital, your entertainment. But it didn't begin that way. It started with one idea. How can a computer pretend to be another computer? Let's go back to where it all began. The origins of virtualization. Long before cloud storage and virtual desktops, before AWS, Azure, and Google Cloud, there was IBM in the 1960s. Mainframes filled entire rooms humming like metallic giants. They were expensive. Too expensive for every department to get their own machine. So IBM asked a question that birthed virtualization. What if one computer can pretend to be many? Using early forms of time sharing, they allowed different users to run processes independently, each isolated, each protected. It was the seeds of modern virtualization. Every breakthrough starts with a limitation. Fast forward into the 1990s, as personal computers grew, powerful companies like VMware revived the concepts. Their creation, the hypervisor. And with it, virtualization leaped from mainframes into desktops of IT professionals everywhere. Hypervisors, behind the magic. To understand virtualization, you must understand hypervisors. They are software or firmware that allows multiple virtual machines to run up on a single physical computer. Type 1 hypervisor, also called the bare metal hypervisors, these run directly on the hardware. Examples: VMware ESXi, Microsoft Hyper-V Server, Xen, KVM. They use in enterprise servers, data centers, and cloud providers, places where performance and stability matter. Then we have your Type 2 hypervisors, also called host hypervisors. These run as applications inside of normal operating systems. Example: VMware Workstation, VMware Fusion, Oracle VirtualBox, Parallels Desktop. These are ideal for labs, education, and desktop testing, where convenience matters more than absolute speed. Type 1 is a pilot flying the plane. Type 2 is a passenger flying a simulator. Virtual machines, the digital blueprint. A virtual machine is a complete system, CPU, memory, storage, network, all simulated in software. As a technician, you define virtual CPU count, virtual RAM amount, virtual hard disk space, network type, whether it's NAT, bridge, or host only, shared folders, graphic acceleration, UEFI, and BIOS firmware type. CompTIA calls these virtualization requirements, and you configure them consistently in the field. Snapshots. These freeze a VM in time, allowing quick rollback, invaluable for labs, malware analysis, OS testing. VM templates, clones, used by IT teams to deploy many identical systems. Every cloud service does this behind the scenes. VM migration, moving a VM from one physical host to another, sometimes while running using technologies like vMotion or live migration. A VM machine is more than a machine. It's a story saved in silicon. Network virtualization. Modern virtualization doesn't stop with CPU and RAM. The network itself can be virtualized. You can have virtual switches, software-based switches inside hypervisors. They connect VMs to each other and to the outside world. Virtual NICs. Every VM gets its own network interface card, fully independent, fully configurable. NAT mode. VM shares the host IPs, good for isolation. Bridge mode. VMs act like a real machine on the LAN, great for labs. Host-only mode. Isolated network between VM and host, perfect for malware labs. And virtualization, networks aren't built with cables, they're built with choices. Virtualization in the real world. As an IT technician, virtualization is everywhere. Scenario 1, testing malware safely. You spin up a VM, isolate it, infect it intentionally, and learn from it. Your physical PC is safe. Scenario 2, supporting legacy applications. The company still uses a Windows XP program? Run it in a VM for security, safety, right? Scenario 3, classroom labs. Students get a virtual machine with standardized imaging. No physical hardware is needed. Great when you're running Access, but you don't have a Windows PC and you only have a Mac. Scenario 4, rapid OS deployment. Need 10 Windows 11 installation? Clone a template VM. Virtualization saves time, cost, and effort. The bridge to the cloud. Virtualization is not separate from cloud computing. It's the backbone. Every cloud server relies on hypervisor, clustering, resource pooling, orchestration, VM scaling. Before the cloud could become the cloud, virtualization had to mature. The cloud is just virtualization at a planetary scale. Into the cloud. Now we step into the clouds, the simmering layer of computing that transformed the world. What began as simple virtualization has become a global platform billions rely on every moment. From startups to mega corporations, universities to hospitals, schools to smart homes, the cloud is the invisible engine powering modern life. Virtualization is the foundation. The cloud is the skyscraper. Let's ascend. What is the cloud? To understand the cloud, remove the mystery. It's just someone else's data center built with virtualization on a massive scale. At its core, cloud computing offers virtualized resources shared across many users, delivered over the internet, on demand, scalable, and elastic. Think of it like electricity. You don't generate it, you simply use it. You pay for what you consume. The cloud works the same way. The cloud didn't change computing, it changed access. Cloud deployment model. CompTIA A+ emphasized 4 major cloud deployment models. Let's bring each to life. 1. Public cloud. Hosted by third-party providers like Amazon Web Services, Microsoft Azure, Google Cloud Platform. Anyone can sign up. You share the underlying hardware with other customers, securely of course. Best for smart businesses, startups, anyone wanting flexible pricing, anyone needed global scaling. 2. Private cloud. A private cloud is owned or dedicated to one organization. It can be on-premise on your own data center, hosted by a third party, fully managed by internal IT, used by governments, hospitals, financial institutions, enterprise with strict compliance requirements. Third one is a hybrid cloud. A hybrid cloud mixes public and private cloud. Sensitive data stays local. Services scale outward into the public cloud when needed. Great for bursting workloads, disaster recovery, organizations transitioning gradually to the cloud. Hybrid isn't a compromise, it's a bridge. Then you have community cloud, shared by organizations with the same mission or regulatory needs, like universities, research groups, government agencies, healthcare collaboration. A rare model, but it's still on the exam. Cloud service models. Now we reach the three pillars of cloud computing. CompTIA demands mastery of all three. Infrastructure as a service. You rent the building blocks, virtual VMs, storage, networking, firewalls, load balancing. Examples: AWS EC2, Azure Virtual Machine, Google Compute Engine. You manage the OS, you manage the apps, they manage the hardware. Platform as a service. Developers rent an environment to build apps. You get runtime environments, databases, APIs, dev framework, automatic scaling. Example: Google App Engine, AWS Elastic Beanstalk, Azure App Service. Don't worry about servers. You focus on the code. Last, software as a service. Applications deliver fully ready to use. Google Workspace, Microsoft 365, Salesforce, Dropbox, Zoom, Slack. You just log in. Everything else is handled for you. SaaS, software as a service, is the reason modern workforce operates anywhere. Cloud storage models. Cloud storage is a core A+ concept. Major types: object storage, used by services like Amazon S3, massive scalability, cheap, great for backup. Block storage, high performance, used for virtual hard drives. File storage, network shares in the cloud like Azure Files or AWS EFS. Cloud storage revolutionized backups, disaster recovery, collaboration, phone and video archiving, software deployment. Your phone right now silently syncs to the cloud storage. Your laptop backs up, probably goes to a cloud target. Your social media, cloud. Your email, cloud. Your streaming services, cloud. Everything is the cloud. Your digital life doesn't live on your device. It lives in the cloud. Virtual desktops. VDI, virtual desktop infrastructure, is a technique where desktop runs from a centralized server. You're not using your computer. You're using a remote desktop session streamed to your device. Perfect for large campuses, call centers, schools, thin clients, secure environments. Examples: Citrix virtual apps and desktops, VMware Horizon, Microsoft Azure Virtual Desktop. Imagine 2,000 employees logging into an identical desktop, all patched, all identical, all controlled centrally. That's VDI. Thin clients and zero clients. Thin clients are lightweight devices with minimal storage, minimal CPU, just enough power to connect to a VDI session. They depend entirely on the server. Zero clients take this even further. No OS, no storage, just firmware. Used where security is critical. Maintenance must be minimal. IT infrastructure wants full control. But a thin client could be something like a Google Chromebook, right? Because everything is handled in the cloud when you do Google Classroom, the Google laptops that the people use in schools. So that could be another example. Cloud networking. The cloud uses virtual networking, virtual routers, virtual firewalls, load balancers, security groups, VPN gateways. When you connect to a cloud service, you're entering a virtualized network space. Every connection is routed, filtered, secure, and logged. All inside software. CompTIA A+ includes VPN connections, remote access, on-demand scalability, cloud-hosted services like VoIP, cloud-hosted applications. Cloud security concepts. Security is when cloud computing becomes critical. Key topics include shared responsibility model. Cloud provider handles the infrastructure. You handle the data, identities, permissions, and configurations. Multi-factor authentication, essential for cloud access. Identity and access management. Who can access which resources? Data redundancy. Multiple availability zones prevent data loss. Encryption, in transit and at rest. The cloud is secure, but only if you are. Edge, fog, and serverless computing. Edge computing. Processing done close to where data is created. Used in smart cameras, IoT devices, industrial sensors, smart cars, environmental monitoring. Fog computing. Distributed computing between cloud and edge. Like mist between the ground and the sky. Serverless computing. You run code without managing servers. AWS Lambda, Azure Functions, Google Cloud Functions. You pay per execution, not per server. The cloud is no longer a place, it's a continuum. We've traveled from mainframes to hypervisors, from SaaS to serverless, from thin clients to global cloud infrastructure. Now we explore the cutting edge layer that defines modern IT. Containers, troubleshooting, cloud connectivity, backup strategies, and real-world A+ operation. This is where theory becomes practice, where technicians turn knowledge into actions. Virtualization built the cloud. Containers and orchestration will build the future. Let's begin. Containers versus virtual machines. Virtual machines simulate an entire computer, hardware, OS, drivers, the whole slack. Containers, they just simulate just the application environment sharing the host kernel. Think of it like this. VM is a whole apartment, and the container is a single room inside a shared house. The advantages: lightning fast startup, extremely lightweight, high density deployment, ideal for microservices, portable across environments. Popular tools: Docker, the most famous container engine, Containerd, and Podman. Containers revolutionized development and cloud operations. Virtual machines created flexibility. Containers created agility. Orchestration, running thousands of containers. If containers are rooms, orchestration tools are the building managers. They deploy containers, scale them automatically, monitor their health, replace ones that fail, balance load, coordinate network. The king of orchestration: Kubernetes, developed by Google, now open source and used globally. Enterprise deployed hundreds, thousands, and even millions of containers daily. Technicians must understand that when they troubleshoot a modern web app, they may be interacting with 20 microservices, running in 20 containers, distributed across 3 regions, managed by Kubernetes, backed by cloud storage, running load balancers. This is the invisible machinery behind apps like Netflix, Amazon, TikTok, even your banking apps. Cloud backup strategies. Cloud backup models are central to CompTIA A+. Here's what every technician must know. File level backups. Only specific folders sync. OneDrive, Google Drive, Dropbox, iCloud. Perfect for end user devices. 2. Image level backups. Full system snapshots stored in the cloud. Used in enterprise disaster recovery. 3. Incremental backups. Only changes since the last backups are saved. Efficient, fast, and used across modern cloud platforms. 4. Differential backups. Store changes to the last full backup. Larger than incremental, but quicker restore points. 5. Offsite replication. Data copied to another region or availability zone. This protects against ransomware, natural disasters, data center outage. Reflection. Backups aren't optional in the cloud. their survival. And if you're in charge of the backup and you're not doing the backup like you should, you are one day going to find out the hard way, if you're not doing your backups right, when it will fail, because eventually it will fail. And if you don't have a good backup, you might not have a job. Cloud printing and cloud-based services. A+ includes a surprisingly practical cloud feature, cloud printing. Example, Google Cloud Print, retired but important historically. Manufacturer Cloud Solutions, HP Smart. Espin Connect, Brother Cloud, benefits. Remote printing, mobile device compatibility. Centralized queues, reduce local driver management. You'll see the cloud printing heavily in school districts, remote offices, businesses with traveling staff, shared workspaces. Other cloud-based services include cloud-based VoIP, cloud authentication, cloud patching systems, and cloud antivirus and EDR platforms. All part of the modern technician workflow. Troubleshooting virtual machines. Now we enter the real technician's arena. Troubleshooting virtualization. Here are the most common issues you'll face and how you will fix them. VM runs slowly. Causes: not enough VRAM, too many vCPUs assigned, disk I/O saturation, host CPU at 100%, background snapshot consuming space. Solution: reduce VM count, increase host memory, allocate fewer vCPUs, clean up snapshots, and move VM storage to SSD or NVMe. Second one, VMs won't start. Possible issues: insufficient host resources, corrupt VM image, missing virtualization support, Intel VT or AMD-V disabled. Solution: enable virtualization in BIOS or UEFI, free up host memory, and restore VM from snapshot. Number 3, VM has no connections. Check. NAT versus bridge mismatch, wrong virtual switch, DHCP disabled on host, firewall blocking VM. Solutions: swap to bridge mode for LAN visibility, reassign virtual NIC, restart virtual switch. 4, VM freezes or crashes. Common causes: overcommitted resources, unsupported operating system, or misconfigured hypervisor tool. Solution: install integrated tools, balance workloads, increase host stability. Every VM is only as healthy as its host. Cloud troubleshooting. End users don't see virtualization, orchestration, or distributed systems. They see: why can't I log in? Why is my drive not syncing? Why can't I print? Why does my cloud software look different today? Here's how A+ techs approach cloud troubleshooting. 1. Identify the problem. Most cloud failures stem from expired passwords, incorrect multi-factor authentication, disabled accounts, IAM misconfigurations. Log in from new device security blocks. Always check identity first. Second, sync conflicts. Cloud storage often fails due to running out of cloud space, file name restriction, offline mode versus online mode, and account mismatch. Number 3, SaaS issue. Remember, you don't fix the service, you fix the client. Check browser cache, app updates, permissions, network connectivity, VPN interference. 4, cloud connectivity. A+ technicians always verify DNS, ping, traceroute, VPN tunnels, proxy settings, local firewalls. When the cloud breaks, the issue usually begins on the ground. The future of virtualization, edge, fog, and beyond. Edge devices now process data when it's created. automobiles, IoT sensors, smart refrigerators, factory reboots, security cameras. Fog computing acts as a local mini cloud between edge devices and the main cloud. And serverless computing is rapidly taking over. No servers to maintain, pay per request, scales automatically, ideal for microservices and automation. The cloud is no longer a destination, it's the default. So let's take a look at our 4 CompTIA A+ questions. You know how we do it here. I ask the questions, I say it 4 times, and then I give you the answers. All right, ready for the first question? All right, let's see if you're ready. Let's try to get 4 out of 4. And if you get 4 out of 4, that means you're almost ready for the CompTIA exam. All right, question 1. A technician creates a VM that shares the host IP address but cannot be reached from other devices on the LAN. Which network mode is most likely being used? A, bridge, B, NAT, C, host only, D, VLAN trunk. I'll read it again. A technician creates a VM that shares the host IP address but cannot be searched from other devices on the LAN. Which network mode is most likely being used? A, bridge, B, NAT, C, host only, or D, VLAN trunk. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the correct answer is B, NAT. NAT mode lets the VM access the internet using the host IP, but other devices on the LAN cannot reach the VM. It is isolated behind the host NAT translation. Bridge would allow full LAN visibility. Host only isolates the VM even further. It can only talk to the host. And VLAN trunk has nothing to do with basic VM networking models. All right. Question 2. Which cloud model allows developers to deploy applications without managing any underlying servers? A, IaaS, B, PaaS, C, SaaS, or D, serverless. Which cloud model allows developers to deploy applications without managing any underlying servers? A, IaaS, B, PaaS, C, SaaS, or D, serverless. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the answer is D, serverless. Serverless computing allows developers to run code without provisioning or managing servers. PaaS provides a development environment but still requires platform configuration. IaaS gives virtual machines full server management. And SaaS provides ready-to-use software, not a development platform. All right, we're halfway there. Question 3. An organization wants each employee to log into a standardized desktop environment that is centrally managed and maintained. What solution best fits this requirement? A, VDI, B, thin provisioning, C, container orchestration, or D, hybrid? An organization wants each employee to log into a standardized desktop environment that is centrally managed and maintained. What solution best fits this requirement? A, VDI, B, thin provisioning, C, container orchestration, or D, hybrid cloud? I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. And the correct answer is A, VDI. VDI, Virtual Desktop Infrastructure, delivers centralized, managed, uniform desktops to many users. Thin provisioning is a storage technique, not a desktop solution. Container orchestration is for server applications, not user desktops. And hybrid cloud is a deployment model, not a desktop technology. All right, hopefully you got 3 out of 3. Let's do the last one and go 4 for 4. A user reports that their cloud storage app stops syncing files. They are signed in and online, but syncing fails repeatedly. Which is the most likely cause? A, corrupt CPU firmware. B, insufficient cloud storage space. C, incorrect hypervisor configuration. Or D, disabled BIOS virtual setting. I'll read it again. A user reports that their cloud storage app stops syncing files. They're signed in and online, but syncing fails repeatedly. What is the most likely cause? A, corrupt CPU firmware. B, insufficient cloud storage space. C, incorrect hypervisor configuration. Or D, disabled BIOS virtualization setting. I'll give you 5 seconds to think about it. 5, 4, 3, 2, 1. The answer is B, insufficient cloud storage. Running out of cloud storage quota is one of the most common syncing failures. CPU firmware corruption is irrelevant. Hypervisor configuration has nothing to do with cloud storage apps, and BIOS virtualization does not affect cloud syncing. All right, raise your hand if you got 4 out of 4. Hopefully you did. Hopefully you're raising your hand up high. Congratulations if you did. All right, let's wrap this up. Virtualization gave us flexibility. The cloud gave us scale. Containers gave us speed. Serverless gave us automation. We began with one physical machine pretending to be many. We ended with millions of machines working together as one. For today's technician, virtualization in cloud isn't just an exam objective. It's a map of how modern IT truly works. I'm Professor J. Rod, and keep tapping into technology. Until next time. This has been a presentation of Little Cha Cha Productions, art by Sarah, music by Joe Kim. We're now part of the Pod Match Network. And you can follow me at TikTok at Professor J Rod, that's JROD, or you can email me at ProfessorJRod, JROD, @gmail.com.